Good afternoon, students. In our previous class, we have talked about the fundamental macroscopic parameters. They are the speed, flow, and density. Today, we shall be discussing about their interrelationship. Now, in this particular figure, you can see that between the 2 points A and B, which are v kilometer apart, the number of vehicles are n1. Less for simplicity. Now, number of vehicles present in a section in an hour is your flow. So, Q equals to N1. Similarly, density is the number of vehicles present in the unit distance. Now, in case of the unit distance, that is V, here it is mentioned as small v. Now, if you multiply the density with the distance, you will get the number of vehicles. Now, suppose one vehicle is moving from point A to point B in the given picture, which is v kilometer apart, and it takes 1 hour to reach from A to B. That means the speed of the vehicle is small v. Now, here N2 is the number of vehicles, N1 is the number of vehicles. If we equate them, or if as they are both the number of vehicles in a v distance, then we can easily get that N1 equals to N2, which means Q equals to K into V. That means flow equals to density into speed. Now, with this particular relationship, we'll be talking about the different interrelationships. Let us start with the speed density curve. In case of the speed density curve, we can see that the line shown with the red color is the assumed line. Obviously, you can easily get different kind of lines depending upon the parameters given, but they will be discussed later. Let us first talk about the straight line, which is mentioned with the red color. What actually happens is that in this particular flow, we can easily get the speed and density. Here, it is the maximum value of the speed. Okay, in the y-axis speed has been taken and it is the maximum value of the speed, but the density is 0 in that particular case. This particular speed is known as the free flow speed. Okay, this means whenever someone is moving in the traffic stream and no vehicle other than that vehicle is present in the stream, he can move in that particular area with his desired speed. Okay, that is known as the free flow speed. So no vehicles are present, he can move with his desired speed. Gradually, as the number of vehicles are increasing, he will need to reduce his speed in order to make some movement inside that particular traffic. So he will need to overtake someone, and as a result, the change in the speed will observe, and as his speed will be decreasing, as the number of vehicles will be increasing, the speed will be decreasing. So that is why this line is shown in this way. The speed is decreasing as the density is increasing. And up to a certain point, this speed will be having some value. But beyond that, the speed will tend to be 0. When the speed will be tend to be 0, when the maximum number of vehicles will be present in that particular area and some jamming conditions will occur. So that is known as the jam density, or in other words, K jam. So at jam density, the speed will be zero. Okay. So in this way, they are interrelated. Let us move to the next relationship, the flow density. Here you can see that this is a parabolic relationship. The flow is having zero value at density is having zero value at two different conditions, at point O and at point C. What actually happens here is that when the free flow speed in the previous picture occurred, that means there is no vehicles present in the traffic stream, and the driver or the owner of the car or any vehicle is moving with its desired speed. That means at that particular condition, flow and density both will be zero. Okay. Now, as the number of vehicles are increasing, which signifies the increase in flow as well as the increase in density, and up to a certain point, this increase in both the numbers will take place. That point is shown here as B in the particular graph. This particular point B signifies the maximum flow condition, here Qmax, and maximum density condition, that is Kmax. No, it is not jam density, it is maximum density. But beyond that, if the density increases in this way, the flow value will decrease. That means the number of vehicles present in that area will increase. As a result, they will not be able to pass, and as they are not being able to pass, the count of the vehicles will be less. So that is why the flow will be decreasing. And up to a certain point, when again the flow value will reach zero, this will be jam density. That means at jam density, the flow will be zero because vehicles are not moving. So that is why this kind of relationship is shown. Now let us move to the third type of relationship between speed and flow. Here you can see that at the first place, this Uf, which is the free flow speed, and at that point the flow is zero. Similarly, as the flow is increasing, the speed will decrease because the vehicle owner or the driver will need to maneuver. Maneuver means to move in a zigzag way in order to make space. Up to a certain point, the speed decrease will happen and it will be Qmax. Beyond that, if the flow tries to increase, the speed will decrease, and as a result, the vehicles will not be able to move. This Qmax condition corresponding to the Kmax condition, that is the maximum density. Beyond that, if they even try to move, they will not be able to move freely. So as a result, the vehicle count will decrease. That means the flow will decrease, and as a result, the speed will also decrease. So up to a certain point, again they will reach the zero value where the jamming condition occurs. No vehicles will be able to move. As a result, the speed will be zero, as well as the vehicle count will also be zero, because the vehicle count the vehicle count in an area per hour is the number of vehicles passing, not the number of vehicles present. If the number of vehicles present we take, that will be density, but number of vehicles passing will be the flow. So in case of the jamming condition, no vehicles are able to move. So that means the number of vehicles passing will be zero. So in this way, these three parameters are interrelated. And I have shown one combined picture where these three interrelationships are given. You can see in case of this particular figure, okay, one flow value here can give us two types of speed values, which actually means that the flow is having a direct relationship with the speed. If the flow do not occur, the speed will have to change. So in both the cases, obviously the speed value is decreasing from here to here, and from here to here, the speed is trying to decrease. But for a particular flow value, we can have two different speeds, as well as for a particular flow value, we can have two different values of density. One is trying to approach towards the maximum density, and one is trying to approach towards the jamming density. So this particular combined diagram is very useful for queuing theory. Obviously, that is not included in your syllabus, so you do not need to bother about that. But just try to remember one particular flow value can have two different values of speed as well as two different value of density. So this is it for today. We'll be returning in the next week with the new notes for this particular traffic parameters. Thank you.